Alrighty then. Okay, I don't care if you don't like my little extrapolations. This is what's behind what we're doing and why we get a parent function, and then from the parent we make what? What do we make, everybody? Baby, you don't want to say it. Baby graphs, babies. All right, here we go. Here's what we're going to be graphing today, everybody. I do kind of like how it shaked out on the board when I did this first hour, but input, say it. So we're going to play the little, I don't know what just happened there. I got to press pause. I already have a technical error. We're back. Okay. Okay, so here's what we're going to do. Y equals, I got to flip this around. I hope this doesn't screw up my, I got to write it like it's a tablet. No. It's useless. Y equals tan of x. Okay, then this is what I did in the other hour. Input, say it. Plug in for x, plug in for y. I'm going to try to make this, I really liked what I did on the board. I'll try to do as good as I can on this one. Now, because I know what happens, I'm going to put 0 right here. And then we're going to do our classic pi over 6. It does make me sad. I don't think first hour just wants to talk to me at all. Must have done something to him. But we should know what the tangent of these angle measures are. And I'm going to talk about this like you being a cat or like a potential calculus student, and the calculus teachers expect you to know these like just like that. And I put this on the coordinate or on the board in the morning, and I put these coordinates here for, well, our first question: what's the tan of 0? What is the tan of 0? This instantly should flash in your head. That coordinate. What is the tan of 0? 0. Okay. Input. Anyone? Actually, I just realized I can't really have this here because I really want to start talking about graphing this. Input, output. So I'm going to put this here, this here. Really bad coordinate plane. This is what I scratched on the board in the morning. Right away, I get to put that point down. Now, this is what I was talking about calculus. This is what you got to be able to think. What's pi over 6? 30 or a 60? We should know at this point. 30. What's the side opposite 30? 1. What's the side opposite 60? Okay, so tangent is opposite 1 over root 3. 1 over root 3, root 3 over 3. Now, you go to your calculator. I'm going to go off of memory from the other class. And I'm going to go out to here and then put these other 3 values in the middle. I don't know, just somewhere around here. I think they're closer than root 3 over 3, I believe 1 over root 3, 1 over root 3. I think it was like 0.7-ish. So here's like 1. So it's like 0.7, 0.6, 0.7, somewhere around there. All right, and then what's tan of pi over 4? 45. What's the side opposite? It's both 45s. 1 over 1. This is 1. Okay. Oh, okay. And then what's the tan of pi over 3? It's not root 3 over 3. It's what? Square root of 3, which is 1.7, which is above 1 somewhere. I made that, so I think it's somewhere right around there. Interesting. Then what's the tan of pi over 2? Here's pi over 2. 0, 1. What's tan? Undefined. What happens with undefined with trig? Because I know someone said whole, but what do we have? I wore the shirt yesterday. Asymptotes. All right, now, do you think we're going to graph these 3 points? No. What I've just identified, though, is a critical value where the asymptote is located. And actually, I just lied. There is one critical value in here. Who do you think the most important value is going to be, because it ends up being nice and easy and even and perfect and beautiful? What number is really nice of these 4 or 3 that I have in the middle? 1. That's going to be a critical value. And lo and behold, what is pi over 4 compared to pi over 2? Half! I'm waiting for my 4th hour to say something. Okay, then did you know that all of these angles are in quadrant 1? This little section right here, right? Right? And tan in quadrant 1 is positive. Do you know when I go over here And I flash this to the other side and talk about negative pi over 6, negative pi over 4, negative pi over 3, and then negative pi over 2, that this is what quadrant? What quadrant is that on the unit circle? That's actually quadrant 4, guys. 4. What's tangent in quadrant 4? What kind of number? Positive or negative? Negative. So then what's tan of negative pi over 6? Look at the tan of pi over 6. And then what is it? Negative root 3 over 3. These are the connections I think some of you are not making. All right? What's the tan of negative pi over 4? Negative 1. What's the tan of negative pi over 3? Negative root 3. And then what's the tan of negative pi over 2, which is down here? 0 comma negative 1. What's the tan of negative pi over 2? Another undies. All right? All right, and then start getting ready to say hello to the parent tangent function, and I'll tell you why. And I did actually do this in the other hour. Doink, doink, doink. Really, all I care about is this negative 1 value. The other values were to denote a point. That, yeah, it continues like this, smoothly through, and looks like this little snake controlled by these two asymptotes. Because if I keep going, and actually this is what I did do in the other class, I kept going. By the way, 1 pi over 4, 2 pi over 4, anyone? 1 pi over 2 pi over 4, 3 pi over 4. What's 4 pi over 4? Pi. What's 5 pi over 4? What's 6 pi over 4? What is it? 3 pi over 2. 3 pi over 2 lands here again. Guess what that is? Another what? Asymptote. And then guess what this separates? This is quadrant 2, and this is quadrant 3. This angle measures in quadrant 3. I'm just sticking with that. Hey, what's tangent in quadrant 3? Positive or negative? Positive. So what's the tan of 5 pi over 4? The same as the tan of pi over 4, which is 1. What's the tan of pi? Pi is right here. I know I'm getting this all smushed together here, but that's the same as the tan of 0 because this is negative 1 comma 0 for that x and y coordinate. And then I'm just hammering the point. What's tan in quadrant 2? Negative. So the tan of 3 pi over 4 is negative 1. Don't you see the exact same graph right here? Yes or no? So what's the period? What's the period? Oh no, what's the period where you get one unique graph? It is pi. And then you can be guaranteed you'll have the same thing over here, same thing over here, so on and so on and so forth. So write this down and lock this in stone, if that's what people say. The period of the parent function for tangent happens to be pi because of what we just did here. This extrapolation that should have some sort of meaning. Now, why did I do the pi over 6 and the pi over 3? Just to see that this connection happens and this flow goes, from the critical points. If I get really close to pi over 2, what did I say pi over 2 is? I already forgot. I think it's 1.5 something. If you take the tan of 1.5, you get a really big number for y. And that's input, say it. So that's what's going on. This is why there's asymptotic behavior. Okay, the range is easy. It's all real numbers. I shouldn't have to explain that. The domain is not a so much. We're going to have to do that thing that we did yesterday or 2 days ago with secant. It's an x cannot equal situation. What can't, are you okay over there? What can't x equal? The undefined values. Give me the first one. Where's the first time that function's undefined? Nice little positive one. We usually like to be positive, just like Mr. Samuelus. And then how far away is each undefined value? Pi. So we add a pi n and understand that n is just some integer. And then what does that mean about the asymptotes? The equations of them? the exact same thing except it's x equals, because they're vertical lines. That's a vertical line equation. And it's x equals these same values that are naughty for the domain. Lock it. Okay, so here is, I said in first hour, I wish I had a highlighter. Here is one period. Okay, that is the parent graph. All right, so just to making sure you understand that, I graphed the second period to prove it. To prove I just get cut and pastes just like in the other trig functions. So on and so on and so forth. Now we should be able to do this quicker. And I did choose colors for in first hour, so I'm going to choose a different color for cots, as first hour said it was. Fast. Okay, I'm not going to do the over sixes. And you know what I'm going to do for cot? Because I know what's going on. I am going to start right at 0 because it's nice. I'm going to put that little coordinate plane off to the right. And even if I was in calculus and my calc teacher expected me to know these real fast, I would still, as a quick catch, draw. Okay, 0, that's that coordinate, 1 comma 0. And what is cotan? What letter over what letter? What is x over y? It's undefined right away. You're actually going to like cotan better than tan. I'm going to go back up to tan after I get done with this cotan graph. To see how cotan is better than tan and what you got to remember for tan and what you got to do. The one thing you got to lock in today, is just these little differences between the two. But I do like referring back to chapter 2 and chapter 1 because you're going to have to know, how to find the cotan of 0 fast again. That's coming back, guys, coming back. All right, then what are my critical values? Well, I'm going to cheat. The next time that cotan is undefined is over here. How do I know that? I referenced it before but didn't write it because that's the coordinate where pi radians passes through. What's negative 1 over 0 yet again? Yeah, answer is undefined. So I'm going to start going input, output, and putting these down. Oh, so for cotan, dot, 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 dot. And then I'm going to go to pi. Dot, 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 dot. And then actually I'm going to get into how you're actually going to graph these things. What do you think I'm going to do to pi next, everybody? Cut it in half. And then we'll input, output. What's the cotan of pi over 2? Well, pi over 2 is right here, and this is 0, comma 1. What does that end up becoming? X over y is 0. Ah. Hey, and by the way, remember the whole quadrant 1, quadrant 2 thing? Pi over 2 separates quadrant 1 and quadrant 2 values. So all I need is this one. Take half of this again, It's the same math as with sine and cosine, and then, of course, secant and cosecant. Now, what's the cotan of pi over 4? Fine, I'll draw for the 1, 1, root 2. What's the cotan? What's cotan of 45? 1. So now we get the, oh, wait a minute. And then has anyone noticed the difference with tan compared to cotan? It what? It's like flipped, right? That should be enough. That should be enough to understand the differences between tan and cotan. Because cotan is positive in 1 and negative in 2. Oh, so what's the other one? 1 pi over 4, 2 pi over 4. Say it, everybody. Same math. 3 pi over 4. I'm just skipping. It don't matter. Don't even have to messing with scale there is all I was going to say. Oh, that's 3 pi over 4. All right, and then if I kept going with another period, quadrant 3, cotan's positive. Quadrant 4, negative, and then you get the same thing. You get the same graph again and again and again. But you know what's easy about cotan? If you wanted 2 periods, you just go over here, right? You just cut and paste. Okay, extrapolation over. I'm going to erase this. I am going to write range and then domain. Do it in a weird way. Okay, I'm going to get rid of that second period's worth. You can understand it. You could do a second period to the left of the origin or y-axis. But the range is all real numbers. How dare you write range first? Terrible math teacher. Domain, algebra 2-way. What's algebra 2? X, people at Lockport don't know what that class is anymore. X does not equal, what does an X equal? What's the first asymptote? 0. Do I have to write that? No. 0 plus, and then how far are they away from each other? You just have to write pi n, because guess what? When you plug in 0 for n, you get 0. You plug in 1 for n, you get this one. You plug in -1, you get the one that's over there, negative pi. You plug in 2 for n, you get the one if I would have kept going right, which is 2 pi. So on and so on and so forth. Sure, I should write n as an element of integers, which in a math book, at least the ones that I've seen in the past, NEZ. For some reason, the letter Z represents integers. Somebody made that decision. And then asymptotes, asyms, are X equals the exact same thing the domain cannot be. Alrighty then. Okay, I will say this before, and I know people are writing this down trying to catch up, but notice what you have to know for cotan. Starts with an asymptote right at the y-axis. Unless, anyone know what Tuesday is going to be? What are we going to do Tuesday? Phase shifts. Of course, that's going to be a problem. That's going to be troublesome. No phase shift, cotan starts at the origin. And then the next asymptote is at pi for the parent. And by the way, the period is pi for cotan as well. That's what you're going to have to know. Tan and cotan are different. Sine, cosine, secant, and cosecant have a period of 2 pi for the parents. So tan and cotan have a period of pi. But what's different about tan pertaining to the period? What do you think you have to do to the period to find the asymptotes? What do you have to do to the period to find the asymptotes? Let's really focus on this number right here and that one and focus on the period. And I'll ask it one more time. What do you think you have to do to the period to find the asymptotes for tan? Divide it by 2. Because tan starts as a coordinate being had as 0, 0. That was bad English, I get it. And then the first asymptote is half to the right of the period and half to the left of that. And you just have to lock it in and memorize. Alrighty, I'm just making a face at him. Memorization can be a problem. Okay, did I say that online? Okay, now we're making babies. Actually, baby graphs. Babies from the parents. Y equals tan 2x. Hope you like my chicken scratch. You okay? You look like you're lost. You good? Oh, I forgot. Let's see. You ready for this? Let's see if you can just think for a second. Take 5 seconds before you answer this. What's the amplitude? 5, 4, 3, 2, 1, 0, go. Who said there isn't one? Boom shakalaka. The word amplitude means there's like a high and a low point. And then we found out for secant and cosecant, there was no amplitude because it goes off forever. Well, tan and cotan go off forever, so we could be jerk teachers and ask, what's the amplitude? And what are you supposed to say? None. Okay, but we do want an A value so that we can graph this appropriately. And really, there's not much to do. So we are going to say A equals 1. I know that's confusing, but you're not supposed to say there's an amplitude. But this is a critical value for when we graph it. What's the period? Now, this is with the kicker for tan. It's blank over B. What's the blank now, though? Pi, because the parent has a period of pi, so all babies will be based off of that. They have the same genetic material. What? That doesn't even make sense. All right, but they come from pi over, because of the, whatever. All right, so here we go. I'm going to go right to the graph. There's really nothing to do with this. There's no work to do off to the side. Of course, when we have phase shifts, then we got a problem. We got to worry about that and do work off to the side. So what do I put right here and right here? What do I put right there? Do I put pi over 2? No, what do you put there? You're not listening. Pi over 4. Here's why. And why is this still 0? And this makes me angry when students don't understand this. Wrong. What happens when I plug in 0? What's 2 times 0 still, everybody? 0. What's the tan of 0 still? 0. That's it. That's why 0, comma 0 is a point there. Now, what did I just say here? The asymptotes are half of the period a distance away. Here's a reason. What's 2 times pi over 4? This makes me sad how many students don't know how to do that really fast in this class. It really does. What's 2 times pi over 4? Pi over 2. What's the tan of pi over 2 still? Nobody knows. No. Oh, yes. I'm sorry. Yes, you're right. You're right. It's undefined. My bad, dog. Rough. So when I plug in pi over 4, I actually get pi over 2, and then I tan it, and then I get undefined again. So yeah, that's why that's where the asymptote is. That's thinking beyond of just how do I get the answer? How do I get the picture? All right, and then what's this number right here? What do you think we're going to put there? Pi over 8. Do you know what happens when you plug in pi over 8 into the function? 2 times pi over 8. What's 2 times pi over 8? 4. What's tan of pi over 4? 1. So this is the new 1 value. I'm going to put 1 here. So this is all I really care about. Where are the a values? Where are the asymptotes? Where's the 0? Those are the 3 critical points, or 4 in this case. And then all you got, this is what's not bad though, is all you have to do is flash it to the other side for, and then same thing with negative pi over 4. Oh, it's going to be right over the pi over 8. I hate when that happens. And it's smooth. I don't like little squigglies in the middle there. Smooth. Hey! Oh, I have a question. Let's stop. Let's not. Let's stop. Do understand it is still 5 critical points, just like sine, cosine, secant, and cosecant. Fumble. Not really. And then, my left wrist hurts. This is really hurting me. Can someone be my assistant and hold the tablet while I walk around? All right. 1 pi over 8. 2 pi over 8. Anyone? 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 3 pi. What am I doing now? 4 pi over 8. Uh-oh, I got to erase this. 4 pi over 8. Pi over 2. What's pi? What? Oh, my brain stopped. 6. Wait. 3 pi over 8. 4 pi over 8. 5 pi over 8. And then 6 pi over 8. I'm doing a second period. And that's all you got to do. Everything's pi over 8 away. Oh, gosh. How many people still can't do this? I cry when I'm grading tests. Remember I told you how many? 11 out of 17, right? First hour? 11 out of 17 that I've graded so far are prize winners. Do you know the other 6? 5 of them are Fs. How is that happening? Did I do something wrong? I was never good at math. 3 pi over 4. There's evidence. I knew it. Okay, 6 pi over 8, 3 pi over 4, right? My bad, dogs. But I was in the middle of a rant. 11 out of 17 prize winner A's. The other 6, 5 are F's. Maybe 4 are F's. It's pretty much true. Just, how does a teacher assess? What do you do? What do you do? Just got to tell them, hey, you're one stage away from, you may not do math in college, but you're one stage away from being on your own. And it's only you that can get the results that you want. Nobody else. Would you like fries with that? By the way, I'm going to Arby's today. They have fish sandwiches there, 2 for $6. All right, what's the next one? Hey, can you read the one in the back? All right, next one is half cot 2x. Okay, again, this is flat out memorization. And like I said, memorization is a bit of a problem. Cat 2x, didn't we just have tan 2x? Let's change it. Let's change that 2 to a 3 just for giggles. And I'll show you how it really doesn't matter. But I think we need some more fractional work and stuff. Okay, so a little bit different than first hour. And the half really doesn't have too much meaning. Because we don't really, scale it. We just kind of put A as half. Remember, don't say amplitude, but we do need to know A as a half. Then what's the period? It's just pi over 3. Okay, here's what you got to know about cotan. And it's because, I don't care if you don't want to know the because, I'm still going to tell you. It's because, whoa, when I plug in, well, let's start with 0. When I plug in 0 for x, I'm still taking cotan of 0. And cotan of 0 is still undefined from my teaching from looking at the parent. So cotan starts with an asymptote and ends with an asymptote. That's why cotan's easier. So you just get to go right here and put pi over 3 right there and know that that's the other asymptote. And of course, I'm going to explain it. 1/2 cotan of 3 times pi over 3. What's 3 times pi over 3, everybody? Pi. The cotan of pi is undefined from chapter 2 and chapter 3. So this is why this all makes sense and cotan's easier. This is your escape if you actually understand what you're doing. But then you go to the test and forget. Which one's tan? What do I do with tan? Do I split the thing in half, or is it you just do a real quick analysis? And those are the ones that do well. The others that are robots that just want to get, how do I get the answer? All right, that's the difference. Hey, what's that next value? Half of pi over 3. Someone already yelled out pi over 6. Hey, what's this value? Pi over 12. 1 pi over 12. 2 pi over 12. Uh-oh. Oh, no. What's 3 pi over 12? I want to change that. 3 pi over 12. 3 pi over 12. Pi over 4. And then all you have to do, I'm going to be lazy. You can just put it on the other side for cotan. You go ahead and do that. Okay, but what's cotan? Oh, this is the 0. Again, for my little analysis here, 1/2 cotan of 3 times pi over 6. 3 times pi over 6 is pi over 2. Good. And the cotan of pi over 2 is 0. So that's analysis, about what's going on here. Pi over 12, though, this is where you get those quadrant 1 angles. So this does represent quadrant 1. This does represent quadrant 2 when you plug this in and multiply it by 3. And cotan's positive in 1 and negative in 3. So cotan, or negative in 2, I mean, goes decreasing and looks like that unless it's flipped. And then you can cut and paste this over to the other side. It looks like this with negative pi over 12, negative pi over 6, negative pi over 4, negative pi over 3. Hey, let's do this one time. I didn't do it in the last one. We don't have to do it every single time. Range. I'll do when I do another tan, I'll do range and domain. Domain. X such that x cannot equal. Well, cotan's easy. What's the first value that it can't equal? 0. I'm not writing it. Plus, how far away is each asymptote? Pi over, it's the period. And then what does that make the asymptotes equations? Ain't no thing. X equals pi over 3n. Chicken wings. Those are good too. Press pause for those writing catch up. Okay, last one. You know what? I think I'm going to change it. It was too easy. Y equals, what did that say up there? Tan 1/2 x. And then anything in front? Oh, I have another cotan, but I don't know. Let's just turn it into that last. What does that cotan say?
1/2 cotan.
Let's do 1/2 tan 4x and call it a day. I think I overnote it sometimes. The thing's established. It's done. Okay, but I want to do a tan because it's harder. The only reason it's harder is you got to split the asymptote, the period in half, and you already know that. And I don't care about a half. You know what? Forget this. Let's make it 7. Who cares? You know what you're going to do. You're just going to go like this and go like this. And then whatever that A value is, you're just going to put it right there. Right? Okay, but realistically, 2, 3, 4, 5, 6, 7, that point's way up there. And I'm just going to kind of show that and understand that this is a vertical major stretch if I made it 7 tan, right? It'd be a super skinnier looking, but it's still confined by asymptotes that are, whatever they are. Okay, so what's the period? What's the period? It is, it's flat out pi over 4. Okay, so what do I do for tan? Do I put pi over 4 there? Or what do I do? What's the rule? The rule is you take half of the period. This is half the period. This is half the period. That equals the full period. So it's because when I plug in pi over 4, no, that's not what I wanted to do. When I still plug in 0, the tan of 4 times 0 is still the tan of 0, which is still 0. All right? And again, that's from this. According to plane, tan is y over x, 0 over 1. Can still do that in a microsecond, even if my calculus teacher said, you're supposed to have that memorized. Well, I could do this real quick and get it. Now when I plug in pi over 8, I know you hate that I do this, but pi over 8 times 4 is pi over 2. The tan of pi over 2 is undefined. So when I plug in pi over 8, I get undefined. There you go. So it's always half the period that asymptote occurs for tangent. Cotangent, it's a full period because it starts with an asymptote and ends with an asymptote. There can't be much more I could do for you. Now it's your turn. It's done. It's established. Now you do something with it. Okay, now this does represent quadrant 1, believe it or not. When I plug in, the last time I'm going to do this. When I plug in pi over 16, 4 times pi over 16 is pi over 4. The tan of pi over 4 is 1, but now it turns into 7. This is what I mean about it being stretched if you really wanted to do it. I'm not going to. I'm actually just going to call this, but you know, we mess with our scale. It makes all of our graphs look the same. I said this, that we do some scaling. So we get lazy and we just call this 7. And then therefore the point is right here. Right? And we should understand that at this point in our mathematical careers. So the graphs do look different comparative to each other and all these things. There we go again, right in the middle. All right. I'm going to erase that so you understand I just rescaled that 7 back. And then I'm going to erase this because 1 pi over 16. Here we go, everybody. 1 pi over 16, 2 pi over 16. Anyone?
3 pi over 16.
4 pi over 16. Ooh, what's 4 pi over 16?
Pi over 4.
Pi over 4. What's 5 pi over 16?
5 pi over 16.
What's 6 pi over 16? This is the same training for sine and cosine. That's why I'm not explaining this anymore. What did I say? 6 pi, 3 pi over 8? Discount, double check. 7 tan 4 times 3 pi over 8. I just want to make sure that's an asymptote. Oh, that becomes 3 pi over 2. Nice. 3 pi over 2 is right here. 0 comma negative 1. Tan is y over x. Booyah. 0, 1, negative 1, second period. And then just to end the video harmoniously and nicely, the range, all real numbers. Why do I have to keep writing it? I know that. The domain, all right, here we go. X such that x cannot equal, what's the first one, everybody? What's the first naughty x value, positive? You could write any of these, by the way. Plus, where is that? How far away? How far away is it? The period. Pi over 4n. Sorry, we had a little interruption. Somebody's phone went off. And then the asymptotes are x equals the same thing, and we'll end this little ridiculous show. All done.